Okay, you're going to like this video. This is where we pull it all together with the radian measure of angles and the exact values. So here we go. What's written on the screen is very familiar to you. Today you had your first exact value quiz in degrees, and you had these numbers memorized, as well as the values at the corners of the unit circle. And so now today what we're going to do is we're going to switch from degree measure to radian measure. And so from our work yesterday in class, you know that 30 degrees is pi over 6. Just a real quick review. If we're at a 30-degree angle, right, there would be 6 of them in 180 degrees, and so the pi over 6 hopefully makes sense to you. 45 degrees is pi over 4, and 60 degrees is pi over 3. Okay, you're going to find exact values in radians once you get comfortable with the pi. Is actually easier to find exact values because the reference angles do not ever involve any subtracting or adding to or from 180 or 360. So let me tell you what I mean by that. So anytime I have a radian measure, so let's say I have 5 pi over 6, and I want to find the cosine of that. If I were in degrees, I would be at cosine of 150, and to find my reference angle, I would do 180 minus 150 to get the reference angle of 30 degrees. When we're in radians, we simply look at the denominator, and whatever the denominator is tells us our reference angle. Right? So anytime my rotation angle is over 6, the reference angle is pi over 6. When it's over 4, the reference angle is pi over 4, and when it's over 3, the reference angle is pi over 3. Now some of you, when you start doing the radian measure, you do a quick switch to degrees, and that's okay in the beginning. So for instance, if you see 5 pi over 6, you think of a pi over 6 reference angle, and many of you will then say, oh, that's really the 30 degrees. Then we know that the cosine of 30 degrees is root 3 over 2. And then we draw a quick sketch of 5 pi over 6. We know we're in quadrant 2. So the final answer, the cosine of 5 pi over 6, is negative root 3 over 2. So what I'm saying is that this part right here, in the beginning, might seem to be the easiest way to go from pi over 6 to 30, but I promise after we spend enough time in radians, you'll start thinking in radians as if it's perfectly normal. All right, so let's go ahead and do a couple more of these exact values in radians. What about if I want the sine of 2 pi over 3? So just as I said before, because 2 pi over 3 has 3 in the denominator, the reference angle is pi over 3. And from our table, we can see that at pi over 3, the 60-degree angle, the sine is root 3 over 2. So the sine of pi over 3 is root 3 over 2. So we're almost there. All we need to do is ask the question, is it positive or negative? So remember, this is pi. And so this is 2/3 of a pi, so we're going to be here in the second quadrant, and in the second quadrant, the sine, the y value, is positive, so final answer, sine of 2 pi over 3, is equal to positive root 3 over 2. Okay, is that making sense to you? I hope it is. As with anything, it takes practice, and we'll do a lot of practice here. Let's do a tangent question. What about the tangent of 7 pi over 6? All right, so the reference angle is pi over 6, and we know that the tangent of pi over 6, we have this memorized, the tangent of 30 is 1 over root 3. Okay, now what quadrant is 7 pi over 6? Well, again, if this is pi, 7 pi over 6 is a little bit more than pi. All right, and so we're in quadrant 3, and the tangent is the slope. Slope is positive here, so the tangent of 7 pi over 6 is 1 over root 3. Got it? Good. Let's go ahead and do one at the corners using radians, and then we'll be done. What about if I ask for the sine of pi? Right? So this is the drawing we use for the corners. Here's pi, and it's really important that we have a good sense of where 0 pi, pi over 2 pi, and 3 pi over 2, and even 2 pi come in at the corners. So the sine at pi, and this ordered pair is negative 1, 0, is nothing more than the y value at pi, or 180, and so the answer is 0. All right, that was a really quick video. I think that you're going to do well with this with enough practice. You'll do as well on the radian exact value quiz as you did on the degrees. See you in class.